Let's do a problem from your lab assignments. This is from section 2.7. It says here that find an equation of the tangent line to the curve at the given point. So given point at 64, comma 8. So step 1, to find the equation we need to find the slope at that point, and for the slope, as of now, we're taking the limits of the secant lines. So we want a slope at 64, comma 8. We know that at 64, comma 8 is a point on the line, so we just need to find the slope. And the slope is going to be given by the slope of the tangent line. So m is our variable for the slope. TAN stands for tangent line. That's going to be limit as x approaches a of f of x minus a divided by x minus a. F of x minus f of a divided by x minus a. In this situation, the function is the square root of x, and a is equal to the x value of your point, and that is 64. All right, now let's take a look at the limit. So the limit is going to be this expression. Again, it's the limit as x approaches a of f of x minus f of a divided by x minus a. And here they gave us our f of a slot. So f of a is equal to 64. F of x is, once again, the square root of x. And so in the next step, I think we still continue to put square root of x, and then they did the work for us to figure out what the square root of 64 is, and that's just equal to 8. Now, as a trick here, we're going to factor, now x minus 64 really cannot be factored if we're talking about keeping the x's as x's, but it can technically factor as a square root of x minus 8 and the square root of x plus 8. It's like the difference of two squares. The second one is clearly a square. It makes it easy, but even if it wasn't, we can still work that out. But x is not a squared, but the square root of x times the square root of x is equal to x. So x is not a perfect square as we would know it as a perfect square, but it's still equal to the square root of x times the square root of x, so it's essentially the square root of x squared. So that's the denominator. The numerator stayed the same, and our idea here is to factor out the denominator so that we can cancel the numerator. And that would give us just this portion over here, which is a square root of x plus 8. And then now, if we take this limit as x approaches 64, we're going to put 64 here. And when we put 64 here, we're going to get the square root of 64, which is equal to 8. And we got 8 plus 8 in the denominator, and 1 in the numerator, so that's 1 divided by 16. All right, so this is the slope of your tangent line. So now that we found the slope and we have a point, we can use a lot of different formulas, but let's use the point slope formula over here. So we're going to put in the y value of the point, which is 8. We're going to put in our slope, which is 1/16, and we're going to put in the x value, which is 64. All right, so solving for y, we have 1/16 times x. And then we have to distribute the 1/16, so the 16 times 64 divided by 16, I think, is equal to 4. and then we have -4, and then we're going to add 8. So -4 plus 8, it is maybe +4. So some people do the y equals mx plus b business, and then you can find it that way as well. All right, I have my graphing program here, and I'm interested to see what happens. I guess I'm interested to see what happens at 64. So 64, the square of 64 isn't going to go past 8, so I'm going to readjust my axes to go all the way up to maybe 70 here, and then my y-axis to just go from -10 to 10. I guess it doesn't really matter. So I can get a good look at this kind of squished. And if I'm graphing this, I want to go to 64. There he goes. 64,8 is our graph. Okay, so maybe I'll extend the x-axis to go a little bit farther. Instead of just going to 70, let's go all the way up to 100. All right, so at this point 64,8, we want a line through that. So let's put our equation of the line, y equals 1 divided by 16 times x, and then plus 4. And then we can see that these two graphs intersect at that point, 64,8, and then that line is in fact tangent at that point. Okay, so hope this helps.